Hello everyone. Today we are going to discuss amplitude modulation in brief. We are revise the amplitude modulation in this particular session. What is amplitude modulation? The amplitude of the carrier wave is varied in accordance with instantaneous amplitude of the modulating signal, keeping its carrier frequency and phase constant. While varying the amplitude of the carrier, we have to kept the frequency and phase of the carrier constant. So it is the part and parcel of the analog communication system. It is one of the part of analog communication system, that is amplitude modulation. So let me discuss. It is the AM wave, amplitude modulated wave. It just follows the envelope. So it is the message signal or modulating signal. It is the carrier signal. The carrier characteristics are varied with respect to the message signal. The carrier amplitude is varied with respect to the message signal. With respect to the message signal, the carrier characteristics, that means the carrier amplitude is varied. Then we can get the amplitude modulated wave. It is the amplitude modulated wave, just follows the envelope. So some of the equations for the AM wave, some of the formulas involved in amplitude modulation are: equation for the AM wave is S of t equal to AC into 1 plus mu cos 2 pi fmt into cos 2 pi fct. So clear? And modulation index is denoted with mu equal to AM by AC, and amplitude of each sideband is mu AC by 2, and upper sideband frequency FC plus FM, lower sideband frequency FC minus FM, and bandwidth is 2 FM, and total power, that is PT equal to PC plus P USB plus P LSP. Total power is the carrier power, upper sideband power, and the lower sideband power. PT equal to IT square into R. It is the general form of the AM wave. It is the modulation index formula, that is AM by AC there. So these are the formulas involved in amplitude modulation. So power in each sideband. The power is PC into mu by 4. Total sideband power is PC into mu square by 2, where mu is the modulation index. So the another important formula is transmission efficiency. It is also very important, that is mu square by 2 plus mu square. It is the transmission efficiency formula. What is carrier power? Carrier power PC equal to AC square by 2R. Maximum frequency in AM wave is FC plus FM. Minimum frequency is FC minus FM. Modulation index from AM wave, mu equal to Amax minus Amin by Amax plus Aminimum. This is the another formula for the modulation index. So it is one of the formula for modulation index, mu equal to AM by AC. Another formula is Amax minus Amin by Amax plus Aminimum. So modulation by several sine waves, it is the multi-tone modulation. So AM with two modulating signals. If analog modulation has two message signals, then we are using this particular formula. General equation for AM is then the particular time general equation is S of t equal to AC into 1 plus mu 1 cos 2 pi fm1 t mu 2 cos 2 pi fm2 t into cos 2 pi fct. Okay, it is the carrier frequency FC ante. FM means it is the modulating frequency. FC stands for carrier frequency, FM stands for modulating frequency. Transmitted power in case of a multi-tone modulation, that is PT equal to PC into 1 plus mu 1 square by 2 plus mu 2 square by 2. Total modulation index or effective modulation index is given by mu equal to mu 1 square plus mu 2 square. Total power equal to PT into PC into 1 plus mu 2 square by 2. We are not going to derive any relations. It is just a revision session. Okay, and it is the total power, that is PT equal to PC into 1 plus mu 2 square by 2, and amplitude of AM wave is A max equal to AC into 1 plus mu square and A minimum equal to AC into 1 minus mu square. So the modulation index, we had already known about it, this formula. So this slide is self-explanatory. Please go through this slide to get a clear understanding of this particular concept. And what are the generation? How we can generate the AM signal? By using the square law modulator and the switching modulator. It is the square law modulator and it is the switching modulator. In case of a switching modulator, we are using the diode. So demodulation, modulation and demodulation. And demodulation is just a reverse process of the modulation. So demodulation of AM signal is a square law detector and the envelope detector. Square law detector uses the VCO, voltage controlled oscillator, and envelope detector uses the diode. So other forms of AM are DSB-SC. AM is also called DSB-SC, that means full carrier. Double sideband full carrier is also called the AM. And other forms are DSB-SC, double sideband suppressed carrier, single sideband suppressed carrier, independent sideband, and vestigial sideband. These are the types or other forms of the AM. And DSB-SC. DSB-SC equation is, it is the time domain representation, it is the frequency domain representation. In time domain representation, S of t equal to C of t into M of t. So the formula is AC into cos 2 pi FCT into M of t. M of t is the message signal. C of t means carrier. So if you convert into frequency domain, just take the Fourier transform. So S of f equal to half into AC into M of f minus Fc plus M of f plus Fc. Okay. How can we generate the DSB-SC? The DSB-SC is generated by using the balanced modulator. It is the circuit diagram of the balanced modulator. And DSB-SC is generated using the balanced modulator and the ring modulator. It is the ring modulator circuit. In ring modulator circuit, we are using the 4 diodes. I am not going to explain the operation of this particular diagram or ring modulator. It is just a revision session. Remember, guys. So the frequency spectrum of DSB-SC, it is the frequency spectrum. So it is LSB and USB. So in case of if you see here, guys, the bandwidth in case of a DSB-SC is 2 FM. 2 FM is the bandwidth of DSB-SC. And various power relations in DSB-SC are P DSB-SC, total power equal to upper sideband power plus lower sideband power. Upper sideband power and lower sideband power equal to K square into Vc square by 8 into R. So the total power in DSB-SC is K square by Vc square by 4 into R. Okay, it can also be written as K square by 2 into PC. Okay, 66% of power is saved in DSB-SC when compared to DSB-FC. AM is also called DSB-FC due to the absence of carrier is modulated wave, right? And next one, SSB. All these are the various forms of the AM. That means AM is also called DSB-FC. So a single sideband AM signal is represented mathematically by, it is the general form of the SSB. S of t equal to Vm into cos 2 pi FCT plus or minus Vm cap sin 2 pi FCT. Here the Vm cap is the Hilbert transform of the message signal Vm. Okay, negative sign represents the upper sideband and positive sign represents the lower sideband. Here it is the frequency spectrum of the SSB wave. Okay, the various power relations in SSB wave are PSSB, the total power equal to V square LSB by R and V square USB by R. The LSB power is LSB or USB power is upper sideband or lower sideband power is V square by R. So the total power in case of a single sideband, it is the total power relation. The power relations are very important while we are solving the problems. The total power involved in SSB is K square by 4 into Vc square by 2R. That means upper sideband power plus lower sideband power. No. So the total power in case of a single sideband is K square by 4 into Vc square by 2R. So it can also be written like this: K square by 4 into Pc. K square by 4 into Pc. Here Pc means Vc square by 2R only. Okay. Clear? You have to remember the general form and power relations. And VSB, vestigial sideband. It is also called the asymmetric sideband system. The general form or mathematical representation of VSB is S of t equal to Vm by 2 into cos 2 pi fct plus or minus Vm by 2 into sin 2 pi fct. Vm by 2 into sin 2 pi fct. Here we are using Vm of q. Vmq, that means it is the quadrature phase component. So it is the quadrature phase component. Vm by 2 cos 2 pi fct plus or minus Vmq by 2 sin 2 pi fct. Here this part is the quadrature phase component. So it is the frequency spectrum in case of a vestigial sideband, and the total power involved in vestigial sideband is K square by 4 into Pc plus f of K square by 4 into Pc. It is the total power involved in case of a vestigial sideband. It is the combination of the LSB plus USB power only. So it is the comparison of different forms of the AM. So if you see there, the carrier suppression. The carrier suppression is, in case of a DSB-SC, is fully carrier is suppressed. In case of a DSB-SC, SSB and VSB, the carrier is fully suppressed. So in case of a sideband suppression, in sideband suppression, in SSB only sideband only SB completely, and in VSB only sideband suppressed partially. Here the sideband suppressed is done completely in case of a SSB. Here in case of a VSB, sideband suppressed is done partially. We are doing nothing there. So NA means nothing. Bandwidth. The bandwidth requirement is 2 pi FM. In case of a DSB-SC, it is 2 pi FM. In SSB is FM. So the bandwidth is lies between FM to FM. Okay. Transmission efficiency is minimum. In case of a DSB-SC, it is moderate. In SSB, it is maximum. In VSB, it is moderate. Number of modulating inputs or message inputs are, in case of a DSB-SC, there is only 1. In case of a DSB-SC, there is 1. In SSB, there is 1. And VSB, there is 2. What is the application? Application is very important, right? Application: DSB-SC is used in radio broadcasting, and DSB-SC. DSB-FC means AM only. DSB-SC means radio broadcasting. SSB, point to point mobile communication, and TV video transmission. It is the speciality of VSB. VSB is used in the TV video transmission. Power requirement to cover same area is, in case of a DSB, it is very high. In case of a DSB-SC is medium. In case of a SSB, it is very small. In case of a VSB, it is moderate. Complexity involved in case of a DSB-SC is very simple. In DSB-SC, it is simple, and SSB complex, it is simpler than the SSB. Carrier is fully suppressed in DSB-SC, SSB and VSB. So sideband is suppressed completely in SSB, and sideband is partially suppressed in case of a VSB. So the sideband is not suppressed in DSB-FC and DSB-SC. So the carrier is not suppressed in case of a DSB-FC. It is the explanation regarding this particular table. And what are the advantages and disadvantages of the AM? AM receivers are very simple and detection is also very easy. AM receivers are cost effective. AM waves can travel a longer bandwidth. Power is wasted in case of a transmitted signal. So all these are the drawbacks. Power is wasted in transmitted signal. AM needs longer bandwidth. AM wave gets affected due to noise. All these are the drawbacks of the AM. And what are the applications? Radio broadcasting, picture transmission, etc. So radio broadcasting is the application of the AM. DSB-FC means AM wave only. Okay. Thank you guys.